Hello and welcome again to another episode of Chemistry Problems. How do you solve them? Today we're going to be putting some uh, freezing point depressions to work. We learned in the last video how to calculate a freezing point depression, but what could it do for us? Why do we care? Okay, well, one of the reasons we care is because we can make ice cream using that way without using like a freezer or whatever. And unfortunately, we didn't get a chance to do that because we weren't in class in physical school. But there's other things that we can also go ahead and do. One of them is to figure out a molar mass. You'll recall molar mass, right? Remember, it's like if you had something like C. Let me get a pen working here. C6H, 12O6. You can figure out how much 1 mole weighs. 1 mole, how much does it weigh? Remember, you go ahead and you look up the atomic masses. 12 carbon is, if I look on the periodic table, carbon's atomic mass is 12.0, hydrogen's is 1.0, and oxygen's is 16.0. Since there are 6 carbons, 12 hydrogens, 6 oxygens, I go ahead and multiply all those together, and I would go, all right, well, I'd figure this out and go, okay, well, there's 6 carbons, so 6 times 12.0, plus there's 12 hydrogens, so 12 times 1.0, plus there's 6 oxygens, so 6 times 16.0. Add all those numbers together, and I'm going to end up with like 180.0. And those are going to be in grams. So 1 mole weighs 180 grams, and we did this back in chapter 11, right? At the beginning of January. And then we get that the molar mass is 180 grams per mole. Now, that is if you know the formula. You need the formula in order to be able to do this. Now, you had already done some other problems, and these were trying to figure out molecular formulas. You had an empirical formula, and you're trying to figure out the molecular formula, and this was another part of that chapter, where you went, let's see, I know the empirical formula was CH2O, because we were able to calculate out an empirical formula by getting a percent of carbon, hydrogen, oxygen, and figuring out what the proportions of carbon, hydrogen, oxygen were. But was the empirical formula just gives you the lowest whole number ratios of carbon, hydrogen, oxygen, right? In order to figure out what the molecular formula was, you need to know what multiple of this was. Was it CH2O? Was it C2H4O2? Was it C3H6O3? Was it C5H10O5? Was it C6H12O6? Which this is what the answer is here. In order to do this, you had to figure out what the molar mass of this would have been. Right, CH2O is about 30. I'm just going to save time, 12 plus 2 plus 16, right? 12 plus 2 plus 16 is 30. So what you needed to do is figure out how many of these there were in the overall formula, since you didn't know what this formula was at the time. And if you were told that the molar mass was 180, and then you had to divide it by the mass of that formula you just come up with, the 30, which was the mass of this formula. And so you took 180 divided by 30, and that gave you 6. And this number you multiplied to the subscripts here to get you this formula. Okay. So these are all things we've done already. I haven't gone over anything new. This is just kind of going back over it. So you needed this molar mass right here. This one, which is this one right here, in order to be able to do this problem. Okay. But how are you going to get, let me go to a different color here. How are you going to get this if you didn't know what the formula was? In order to get this number here, you needed to know the formula, right? How many carbons and hydrogens and oxygens. And so these problems, to some of you guys, may have seemed backwards, because like, well, we're trying to figure out what this is. We're trying to figure out what this formula is right here, but we needed this right here. But if we don't know what the formula is, how can we figure out what the molar mass was? That's where freezing point depression comes in. A little different, makes it a little different. We can figure out the molar mass of stuff without knowing the formula of it. And this problem that we're doing right here, that's exactly what we're going to do. So let me go ahead and move the problem down. Let me go ahead, I need to do this. I'm going to move the problem down to put it in a place where we can see. So that's kind of the gist of this whole thing right here, is when would we use this? How could we come up with that molar mass without knowing the formula, right? Because we need that molar mass in order to figure out the formula. How are we going to come up with the molar mass if we don't know the formula? Up to this point, the only way we knew the molar mass is to add up all the atomic masses in the formula. But if you don't know the formula, you can't do it. This is how you can do it. And let's see right here. I'm just going to show you real quick what's going to be done. We're basically going to make a solution. All right, so here's your solution. And in here, we're going to put 500 grams of water as our solvent. And we're going to drop in 20 grams of this unknown substance. We'll call it substance X. We don't even know what it is, but we want to know the molar mass of it. Right? And so what you're going to do is you're going to first off take the, we know that the freezing point for water starts off at 0 degrees Celsius. And that's for water. What we're going to do is we're going to use the freezing point of our solution. Right, once we've put the substance X into the water, we're going to use that. Then we're going to go ahead and get a freezing point difference. Okay. And the whole idea is this: in order to figure out molar mass, what you need, let's see, for molar mass, I'll put it over here. What you need is grams divided by moles. All right, so this chunk right here, we know that we have 20 grams. The question is, how many moles of this substance went in there? So how many moles was 20 grams, okay, of that chunk? And we're going to use our equations to try to figure out moles, okay, because we have an equation that has moles in it. I'll move that up. All right. You'll recall that the molality equation has moles of solute in it, right? And the substance whose molar mass we're looking for is the solute. And we know that there's kilograms of water here. That's our solvent. So we know how many kilograms. Instead of what, 500 grams? We can turn it into kilograms. We know this. So if we can figure out the moles of solute, then that moles of solute can go into our equation over here. So we have grams divided by moles. Okay. But we don't know the molality. We're looking for molality. However, we can use our freezing point depression. And you'll recall this equation right here. If we can figure out what the freezing point depression is. Kf is a constant. So if we get 2 out of those 3's, we can go ahead and solve for this. Once we get this, we plug it into here. And once we plug it into here, this goes from being a question mark. Let's go ahead and get rid of that as a question mark. And it becomes a known quantity. Now we plug that in there. Now we know 2 of these 3 we can solve for moles of solute, which then goes up to here. And since we know, change colors here, since we know the grams, let me move this down because I don't know if you can see it. If we know the grams, which we already measured, 20 grams, and now we know the moles, we can get grams per mole. Alright, so this helps us get this. Then once we have this, you plug it into here. This will help us get this. And then once you have this, you plug that into the moles over here. And this, along with the grams over here, helps us get molar mass, which is what we're looking for. So let's do that. We're actually going to start off with this equation first, work backwards, then this equation, and then this equation. Okay? So 1, 2, and 3. Okay. Now, before I go ahead and get going with that, I need to bring the question down again, just so we can kind of see it. So we bring the question down here, and move all that work up. Alright, so we've got a new slate going here, and I'm going to go ahead and go back with a black pen. We said the first thing we need to do is figure out what the freezing point depression is. And the freezing point of the solution was minus 1.39 degrees Celsius. So since water by itself is 0 degrees Celsius, that means the freezing point must have dropped 1.39 degrees Celsius. So that's your freezing point depression. Put in this equation. Delta TF is equal to KF times molality. We can look up KF, and KF for water. KF for water is equal to 1.86 degrees Celsius per molal. Okay, so we're going to put this as 1.86 degrees Celsius per molal, and then multiply that by the molality. Okay. And now once we have that, let's get the molality by itself. So we're going to want to solve for molality, which means we need to get it by itself, divide both sides by 1.86 degrees Celsius per molal, divide the other side by 1.86 degrees Celsius per molal. Now these guys cancel, leaving us with a molality of 1.39. Do that on my calculator. 1.39 divided by 1.86 is going to give me 0.747. The number is going to be 0.747, and the molality, the answer is going to be in terms of molality, because the degrees Celsius here cancels with the degrees Celsius here, and leaves you with 1 over molal. And once again, the denominator of the denominator moves to the numerator. Alright, so now we have our molality. Now that we have molality, we can go ahead then and I'll move this up with our molality there. Figure out how many moles of solute there is in there. We'll use this equation next. Molality. Let me undo that. This thing sometimes gets stuck on me. Okay. Molality equals to moles of solute over kilograms of solvent. And if you remember, our kilograms of solvent, we're given that there's 500 grams. And so we're going to go ahead and put it in as in kilograms. The molality was given to us here, 0.747, and I'm going to go ahead and put it as 0.747. In this case, when I use it in this equation, I'm going to put it as moles per kilogram, because I know that my units, one of these units is going to cancel out whenever I plug it into this equation. That's going to equal to N. I'm just going to put N, even though it's N of solute, and multiplied by the kilograms of solvent. 500 grams of water is 0.500 kilograms. And so here's my equation. I need to get N by itself, so I need to get rid of the 0.5 kilograms on the right, which means I'm going to multiply it by both sides, 0.500 kilograms, so that these guys cancel. But because I multiplied it to one side, I have to multiply it by the other side, 0.500 kilograms. Right there, multiply that to this, 0.477 moles per kilogram. So my moles, N, sorry, that got a little crowded, is 0.747 multiplied by 0.5. It was 0.5, right? Let me double check. Yes. And that's going to give me 0.374. 0.374. I don't know why it gets stuck sometimes. 4 moles. Okay, so this is how many moles that I have. Now that I have moles, I can figure out the molar mass. Because remember, I just need grams divided by moles to get molar mass. So my final equation is molar mass. These I can put it directly in. Is grams of a chunk of something divided by moles in that chunk of something. And since the problem said that there was 20 grams, let me go ahead, no, believe me, 20.0 grams divided by this many moles, 0.374 moles, that's going to equal to 20 divided by 0.374 is going to equal to 53.5. 53.5 grams per mole. And there is your answer. Okay, so we were able to figure out molar mass. We have no idea what the solute is, what we've dissolved in our water is. But because we were able to figure out the freezing point depression, we're able to use the equation in order to help us calculate the molar mass. I'm going to go ahead and go back over here just to recap real quickly. Right. So once again, we have 20 grams of your unknown substance dissolved in 500 grams of water. And I'm going to go ahead and go over blue over here. And we were given a freezing point depression. And thanks to that freezing point depression, we were able to calculate the molality. And that molality ended up being 0.747 moles per kilogram, or molal. And then once we had that, using the freezing point depression, we were able to plug it into the definition for molality, and that is right here. This is the definition for molality, and we were able to plug this number into here. What was this number right here? And since we knew the kilograms of solvent right here, or we can figure it out, we're told 500 grams of water, 500 grams is 0.5 kilograms. Now all we have to do is look for N. Okay? And so once we solved for N, N was here. That was our moles. And once we had those moles, we used them right here in order to figure out what the molar mass was. We took the 20 grams that we were told, divided it by the moles we just calculated, and that gives us how many grams there were per mole. Okay? And so here is our answer. Okay, so I hope that was helpful to you. This one's a little bit longer problem, but that's because there was three steps. There was three parts to it where we had to use three different equations in order to get to where we wanted to get to. You might have to go over it again just to kind of get an idea of what was the plan here, why did we use three equations, which was the equation in the end that allowed us to figure out what the question was asking for is really not an equation that we learned directly, it's indirectly. The molar mass is how many grams there are per mole. So once again, if you have a chunk of something and you know how many grams there are in there, and you also know how many moles there are in there, even though you don't know the relationship between the two because you don't know the identity and therefore you don't know how many, you don't know the formula. If you can get these two quantities here from different places for the same chunk, you can take the grams divided by moles and that'll give you your molar mass. Okay? All right, so I will see you later online.